All right, so today we are going to talk about domain and range. We're going to review the definitions of the definition of both domain and range. We're going to talk about finding domain and range given a graph or like a graph of a relation or a graph. And we're also going to do it in interval notation, not inequality notation. Okay, so domain. What is domain? Domain is all the x values of your function. So when you have a graph, we got a y-axis and an x-axis. When you are looking at your graph, and I'm asking you for the domain, you only need to look at what values does that function hit on the x-axis, okay? We do not worry about the y for domain. Also, it is all the numbers that can be plugged into your function. So for example, your square root function that you learned in Math 2. You know you cannot take the square root of a negative number, so therefore my domain would not include negative numbers. But then when you have its inverse, the quadratic function, we know that we can square any number in the number system, so therefore the domain for a quadratic function would be all real numbers, okay? So we order your domain from least to greatest. So if we were finding the domain of this relation right here, this is my domain, okay? And it needs to be ordered from least to greatest. So it's -1, 2, 3, 5, and 7, okay? Now, quick side note, these points cannot repeat to be a function. So to be a function, x values cannot repeat. Okay, so if my x value is repeated, it cannot be a function. Okay. All right, your range. Your range is going to be the y values of your function. So if you had a graph, an xy axis, again, that's my y, that's my x. When you are finding the range of a function, you're only looking at the y axis, okay? So if I said to find the range of a function and I give you a graph, you only need to be concerned with how low does it go to how high does it go, okay? And does it skip anything in between? All right, next. Your range points, they depend on your x values of your function. If you can't plug this certain x value into this function, then you're not going to have that point on your range, okay? You also order this from least to greatest. So if we were finding the range of this relation right here, we would write it from least to greatest, -2, 0, 1, and 4. Now you see -2 was twice. We did not write it twice. We wrote it once. All right. So I want to create an ordered pair. An ordered pair is made up of x and y axis, or an x and y value, sorry. X is your input, y is your output, okay? So I want to find f of 5. This is what we call function notation. All right, you're used to me saying that x equals 5, now find y. But if you recall, function notation looks like this. The 5 is replacing that x. So that means I want to replace all of the x's in this function with 5. And that'll give me my output. Okay? So when I plug 5 in, that's my x value because it's where x is. Okay, I'm going to plug it in. So I replaced all my x's with the number 5. Use your calculator, use Desmos, or you can do it in your head. So when I calculate this, what comes out is going to be 65. So my ordered pair here is 5, 65. Okay? All right. So looking at this graph, I want to find the domain and range. Now, if you notice, there is a closed dot and there's an open dot. There are not arrows here. Okay? So recap on interval notation. If it is a closed dot, it is going to be a bracket situation, okay? Because that means you can include it. If it's closed, it means it's included in the graph. If it's open, that means there is a gap, and that number is not included. So that means that I can have every number all the way till I get to 2. So I can have 1.999999, but I can't have 2. Okay, so in order to represent the 1.99999, we have to do parentheses. And that parentheses saying that you go close to 2, but you're not 2. Okay, so open dot means parentheses, closed dots means bracket, and arrows are always parentheses because an arrow signifies it's not stopping. So you can't bracket it if it's going to keep going. Okay, all right, so domain. Domain is going to be, so I said earlier, domain is going to be your x-axis, okay? So my domain is going to be basically how wide is your function, all right? Where does your functions, and it's from left to right because on an x-axis, least to greatest is left to right, so just like you read a book. Okay, so domain is how wide is this function, okay? So what is the smallest number that is included on this function? Well, that's right here, okay? And that's going to be -2, all right? So it starts at -2. And then if I take my pen, okay, if my pen's not lifted, then it's a continuous function and I have no holes or gaps and I don't have to do a union. Okay, and we'll talk about that more in the next examples. All right, so I start at -2. I've got a graph, I'm good, graph, 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 graph. But I stop here, and where I stop is at +2. So this graph is in between -2 and 2. Now, this is where the closed and open dot, the closed dot and open dot comes here. So this is -2 is a closed dot, so that will be a bracket. +2 is an open dot, so that is going to be a parentheses. Okay? All right. Now, your range, race, okay? All right. Your range is how tall is your function. How low, let's change colors. How low does your graph go? So how low does this graph go? Okay, to how high does this graph go? All right, so how low do you go to how high you go? So if you look, the lowest number here, and remember, it is your y-axis, range is your y, okay? It goes as low as -1, so that's my lowest point. Now how high does it go? I got a hump here, but I still got more graph up here. So my function goes as high right here. That's in between 1 and 2, so we're going to say 1.5. All right, so it goes as high as 1.5. Now, right here, my -1's a closed dot, so that's a bracket. My 1.5 is an open dot, so that is a parentheses. And that is your domain and range for this function. Okay? All right, next one. We're going to do the same thing. Now, if you look, these are arrows. Arrows are parentheses. Okay, they are not brackets. So, now this is a little different. Okay, so your domain here is how wide is this graph? All right, well, the last page we were on, it had the dots, and so it stopped. So I could tell how wide that graph was. But if you look here, the graph doesn't stop here, does it? No, it keeps going. And if you look, it's going to keep going. And what is happening to this function? It's getting wider and wider. And it's going to keep getting wider. Well, if I keep getting wider on the left-hand side, my x's, where are my x's going to? They're going towards -infinity. So that means my domain is -infinity. Okay. Now, same here. My graph doesn't stop there. My graph's going to keep getting wider and wider and wider. So it's going to keep going to the right. Well, who is on the right? what do my numbers go towards on the right-hand side of my x-axis? Well, that's positive infinity. So my domain here is negative infinity to positive infinity. And we also can say that's all real numbers. And you just do a little sign like that. That means all real numbers. That means there is no number that I cannot plug into this function. Okay? All right. Next is going to be your range. Okay? So my range, let's erase our domain work. Your range is how low do you go to how high you go. Well, I have a low point here, correct? Like my graph stops right here. There's no more graph down there, right? So my graph starts at -2. And then how high does my graph go? Does my graph stop here? No. Does my graph stop here? No. Does it stop where this arrow is? No, that arrow is pointing, saying, all right, this graph is going to keep going up, 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 and away. Well, who is up for my y values? What is my y values approaching when it goes up? It's approaching positive infinity. Now, this is a closed dot, so it's going to be a bracket, and infinity is always parentheses. So this graph is going from -2, starting at -2, and it's going all the way up, and it'll keep going up to positive infinity. Okay? All right. So let's do some more examples. All right, some more examples. Now it tells you to state the domain and range for each graph, and then okay, so number 1. Let's zoom in to number 1. All right. So I want to find the domain and range of each function and then tell me if it's a function. Now, a function cannot repeat your x values, and it has to pass the vertical line test. Okay, that's what a function. So to be a function, you have to pass your vertical line test, and x's can't repeat. Okay? All right. So the domain here. Now, this, number 1, is what we call a relation. It's a graph of a relation. So the points aren't connected. So we're going to do what we did in this slide when I was doing the examples of the table. You're just going to write your x values from least to greatest. Okay? So, all right. So we're going to actually do those squiggly lines for a domain and range with a relation. So just write your x values from least to greatest. Well, my first one is -3. My next one is -2. Next one is 1. You see it twice. You do not have to write it twice. And the next x value is going to be 4. So that is my relation. Okay. Next is range. Okay. So that's your y value. So you're going to be looking at your y-axis for the range. Okay. So start with lowest y value to highest y value. Well, my lowest y value is -4. And then we go and we got a point at -2. Then we have a point right here that's on the x-axis. Remember, that's your 0 y value. Okay, so we got a point at 0. Go up, we got another point at 3. And another one at 5. Okay, so that is my domain. Now remember, you cannot repeat an x value to be a function. So, is this a function? No, this one is not a function because my y values repeat right here. That makes it not a function because it wouldn't pass the vertical line test either. Okay? All right, number 2. Number 2. Whoops. All right, domain. This doesn't look like a normal graph that you've seen, but we're going to be doing different graphs that you haven't seen, and you're actually going to probably end up talking about majority of them in Math 3. Now, some of them you might have seen in Math 2. All right, so domain. This is a pentagon on a graph, okay? but you can still find the domain. So how wide, so domain is like how wide is your function. So my function, so the smallest x value is right here, which is -3. And then if you look, how wide does this function go? It stops at +3. Now, let me erase. Those are both closed dots. Okay, there's no open dot up here. So it's going to be a bracket and a bracket. Okay. Your range is how low do you go to how high you go. Well, my lowest y value point is right here at 4. My highest y value point is right here at 3. Again, no open circles, so bracket, bracket. Now, is this a function? Now, to be a function, it has to pass the vertical line test. So we're just going to draw a bunch of vertical lines. 1, 2. If the function crosses the vertical line at two or more spots, then it's not a function. It hits it here and it hits it here on that vertical line. So no, this is not a function either. All right, next one. Next one is going to be here. Now this one has some open dots, so you're going to have some parentheses, and there's an arrow, so you're going to have a parentheses. So domain is how wide is this function, okay? So if you look, it starts at -4. Sometimes I color in too. It starts at -4 and it hits every point. And now this arrow, does this arrow mean I'm going to stop right here? No, that arrow means you're going to keep going to the right. Well, when I keep going to the right, I'm hitting positive infinity. So this starts at -4 and goes all the way to positive infinity. Now, at -4, that's an open dot. So that would be a parentheses, and infinity is always parentheses. Okay? All right, now, range. How low do you go to how high you go? Well, my lowest y value point is right here at 1. And I'm going to color this one too. I've got function, function, function. Now the function stops here, but does it stop here? No, that arrow means it's going to keep going up, and when you keep going up, you go to positive infinity. So my range here is from 1 to positive infinity. Now, this 1, there's no open dot at 1, so it's going to be a bracket, and then your infinity is always parentheses. Okay? Now, is this a function? Well, let's do the vertical line test. Yes. It does not, the vertical line only each vertical line only touches that graph once. So yes, this is a function. Okay? All right, number 4. So number 4 is a circle, and we'll get into circles later in Math 3. But right now we're just looking at the graph. So domain, how wide is this function from left to right? Well, looks like it's as wide as, it goes as far left as -2 and goes as far right as +2. Now, do you see any open dots? No. If you do not see an open dot, it is an automatic bracket, okay? Or an arrow. Now, your range is how low does it go? Well, it's sitting on that x-axis, so that is your 0 point. And then it is tall as +4. There are no open dots, so it is a bracket and a bracket. Now, is this a function? Let's do the vertical line test. See how it hits the vertical line at 1, 2 spots each time you do it? So that means this is not a function. All right, this is a linear function, which you saw in Math 1. So this one isn't a new one. So how wide is this graph? Well, does the graph stop at -4? No, it's going to keep going. It's going to keep going down to the left. So that means that I'm going to keep going to -infinity over here. And if you look on the right-hand side, I'm going to keep going to the right, correct? So that's going to positive infinity. So my domain is -infinity to positive infinity, or you could write all reals. Now range. Range is how low do you go to how high you go. Well, if you look, I don't stop at 6 just because the graph stops. is pointing down. It's going to keep going down. This line is going to keep going down. And it's going to approach negative infinity. And then this is going to keep going up, and that's going to be approaching positive infinity, which is parentheses, parentheses, or you could write all reals. Now, is this a function? Yes, we know the linear function is a function, okay? All right, number 6 is a graph that you're going to actually see in this unit, okay? But let's just talk about it as a picture that we're just seeing, okay? So domain. Again, arrows mean I'm going to keep going up and to the left. So if I keep going to the left, left is negative infinity. I'm going to keep going up and to the right. Well, that's going to positive infinity. So this is negative infinity to positive infinity. Now, how low does this graph go? It actually has a vertex at -5, so it goes as low as -5. Now, see how the arrows are both pointing up? Well, what's up for your y-axis? Positive infinity. There are no open dots, so this -5 is a bracket, but infinity will be a parentheses. Is it a function? Yes. Okay. All right. Number 7. So, domain, how wide is the graph? Okay, well, the smallest number it hits is 0. And then it keeps going to the right. Now, does it stop going to the right? No, those arrows mean that it's going to keep going even though the graph is not there. It's going to keep still going. And to the right is your positive infinity. So it's 0 to positive. This 0 is not open, so it's a bracket, and infinity is a parentheses. All right, your range. How low does this graph go? Well, this graph it's kind of hard to tell, so I understand. But just think about these arrows, okay? If you look at the pattern, okay, the pattern's saying the y values are getting bigger, correct? So as I'm drawing on this graph, I go from 1, and then I go to 2, and I'm going to keep going past 2. So I'm getting taller and taller. So here, down here, if you look, I start at 0 for my y value. There's -1, and I hit -2, and then I hit -3. I'm going to keep getting smaller, right? You notice -2, then -3, then -4. That's getting smaller. So that means I'm going to be coming from a negative infinity. And then your y's are getting bigger here, so that's going to positive infinity. So my range here is negative infinity to positive infinity, which is all real numbers. Is it a function? No, it is not a function. Okay? Domain and range is very visual. Okay? All right. So the domain here, okay? All right, so this one's a little bit different. It's not a continuous function. And we're going to do more of these when we get to the piecewise section, but I did want to show you one right now. So if you look, the domain, how wide is this graph? Well, that's saying it's going to keep going, right? So that's a negative infinity. So my domain is negative infinity. Now, yes, you see how it jumps from this equation to this equation? But when it jumped, did it skip a number? So this is -1. So when I left this graph, at -1. Where did this graph pick up? It picked up at -1. So did I skip an x value? No, I didn't. So it's not continuous graphically, but your x values, it didn't miss one. So I'm going to keep going to the right up here. And when I'm keep going to the right, that's going to be approaching positive infinity. So my domain here is negative infinity to positive infinity, or all reals, okay? If you have a gap, it's going to be because your graph skips an x value point or a y value point, which leads me into the range. Okay, when I'm doing the range, if you look, my lowest y value is this line which is at 1. Agreed? So I start at 1. Now when I go from this line to this line, did I skip a y value? I skipped quite a few y values. There is a huge gap right here. There's a huge gap right there. Okay? So I skipped the points. I skipped from 1 to 3. I skipped all those numbers. So I left off at 1 and then I picked back up at 3, but I didn't go nowhere, did I? So the only y value points it hits are 1 and 3. Okay? Is it a function? It's not a function at this one spot right here. At this one spot, it has the same x value right here. So that one spot makes this not a function. Okay? And again, we're going to be doing more piecewise in another topic. Okay? All right, last one. So number 9, domain. How wide is your function? Well, this arrow means I'm going to keep going to the left, which is negative infinity. And then I actually stop at 2, but that's open, so that's a parentheses, and infinity is a parentheses. Now, your range is how low to how high you go. Well, my lowest y value point is negative 2. Now, I have a point at 1, right? It looks like it stops at 1, but what does this arrow mean I'm actually doing? I'm going to keep going up, which is positive infinity for your y values. Now, at negative 2, I want to talk about it. Yes, I have an open dot, but I also have a bunch of closed dots. Closed dots, when you have a closed and open dot at the same point, your closed dot trumps your open dot, okay? So I'm actually going to put a bracket on negative 2 and then a parentheses at the infinity. Is this a function? Does it repeat any of my x values? No, it doesn't. So this is a function. All right, that concludes your domain and range video. All right, thanks guys.